This is Euclid Book 9, proposition number 31. This time we have 4 lines. Ta-da! This proof goes like this. If an odd number be prime to any number, it will also be prime to the double of it. For let the odd number A be prime to any number B. Okay. Now remember, A isn't necessarily a prime number. It's just prime to B. Okay? And let C be the double of B. So B times B will now be C. I say that A is prime to C. Okay, now we're going to say that A is also prime to C just as much as A is prime to B. That's what we're going to say. For if they are not prime to one another, some number will measure them. Okay? Let a number measure them and let it be D. Okay? So D is going to somehow be able to measure both A and B. Now A is odd, therefore D will also be odd. Since A is odd, D is odd, because an odd number can be measured by an odd number, obviously. Okay? And since D, which is odd, measures C, okay, since D is odd and it measures C, D measures C and D is also odd. And C is even, now we're going to say that C is even, therefore D will measure the half of C also. So D will measure half of C, which is by Euclid Book 9, proposition number 30. But B is the half of C. Now we're going to start running problems here. Therefore D measures B. Now we're going to say that D measures B. But D also measures A. Therefore D measures both A and B. And A and B are prime to one another. And D can't measure both. That's a problem. That's impossible. Therefore A cannot be prime to C. A is not prime to C. Therefore A and C... Okay. Therefore A cannot be but prime to C. Therefore A and C are prime to one another. A and C are prime to one another. We just now proved that. Alright. I will tell you more in future videos. Stay tuned.